Now, I want to go back to our Kubernetes section. So as far as I'm aware anyway, all of the issues that were a problem back when I started this subject originally are now resolved. So, which is good. So I want to work my way through some of these slides this morning. I'll probably use tomorrow morning some part of it for lecturing as well. Depends on how far I get today. I do have labs in this section, but I've held off on the labs until next week because I'm sure people are focusing on the assignment, which is fine. So let's go back to these slides. And at this stage now, everybody has logged into the Kubernetes cluster. You haven't done it for a while, obviously, but you have the credentials that I gave you to log in. And so Kubernetes, like we have been using Docker Desktop. In fact, even in the assignment, you have Docker Desktop installed on a VM, on an EC2 instance, and you're deploying containers to that EC2 instance. And that's fine, but really in a production environment, that's not the way it would typically work. Instead, in a production environment, we would have Kubernetes instead of Docker Desktop. Kubernetes would be installed not so much on a single VM, but on a suite of VMs, a collection of VMs, which we refer to as a cluster of VMs or cluster of nodes. And you might remember that that cluster of nodes, some of the nodes are classified as master nodes and the others are classified as worker nodes. And the worker nodes are where our containers are deployed to. The master nodes uh, essentially kind of manage the entire cluster for us. There's one main master and then there are backup masters. Now on the cluster that we have, if I just switch over to VS Code, so I've logged in to the cluster there just before the lecture. And the CLI tool that we're using is called OC, which is short, presumably for OpenShift Container Platform, which is the kind of the uh, implementation of the Kubernetes that we're using. It's the Red Hat product, if you remember. So if I just go OC get nodes, then it's telling me that there are three master nodes and two worker nodes. Three worker nodes, sorry. Three masters may seem excessive, and it probably is for our purposes, but you might remember, I mentioned to you that the Red Hat people kind of recommend that for any OpenShift container platform installation, you should have three masters and any number of worker nodes. It doesn't have to be a one-to-one between master and worker. That just happens to be the case here, that there are three of each, but there would typically be many more worker nodes. But as I said, Red Hat kind of recommend that the minimum number of master nodes that you should have would be three. And that's really to guarantee availability and deal with any kind of fault tolerance issues. Um, so that's fine. That's what we happen to have in our cluster. So it might be a good idea actually to go back and do a quick review of the lecture that I gave you on Kubernetes, because we covered all of this stuff back then. And so with Kubernetes, what you kind of deploy are what are called resources. And there are many resources available to us. there's probably not 100, but there are certainly dozens and dozens of different types of resources. Now, we will only deal with a small subset of the types of resources that we can deploy, but the fundamental or the lowest or most primitive resource that you deploy to a Kubernetes cluster is called a pod. And I did talk a little bit about pods to you when we started looking at this topic originally. But as far as we're kind of concerned, there's a kind of a one-to-one relationship between a pod and a container. Now, technically, a pod can contain more than one container in it. Um, and that would be the case, I guess, in many kind of production environments. Certainly not all pods would have more than one container, but some of them would. Now, we're not going to get to see that in action, but just to be aware of it. And whereas in Docker Desktop, when we deploy a container onto our Docker Desktop environment, Docker Desktop assigns an IP address to that container, which is kind of a private IP address. It's internal to Docker Desktop. It's not accessible outside of Docker Desktop unless you do port forwarding. In the case of Kubernetes, an IP address is not assigned to a container, it's assigned to a pod. And you can think of a pod, that's kind of a visual representation of it there. Pod is like a wrapper for your container stroke containers. So an IP address is assigned to a pod in the case of Kubernetes. And equally, that IP address is kind of internal to your Kubernetes cluster of nodes. Um, and when we want to, if we want to scale up the number of instances of a container stroke pod, it's really pod though, each pod then will get its own IP address, and the set of pods that all have the exact same container running within them, we refer to those as a replica set, which is something we'll come on to again in a while. So I suppose we'd really like to do something, right? So the simplest way, but it's actually not the one that you would use more commonly, but the simplest way to create a pod is to use the run command. So this command here is going to create a pod. The name of the pod is Nginx pod. That's a completely arbitrary. You can give it any name you want to. As it turns out now, we'll see that the name we give to a pod is really only for our purposes. Kubernetes internally doesn't use the pod name that much at all. And clearly what I'm saying here, I'm telling here is I'm specifying the image that I want the container, and there's only going to be one container within this pod. If there were more than one, then I'd have more arguments over here. Uh, and there could be more arguments as well about this particular container. Like if I wanted to mount a volume for this container, all of that stuff would be extra arguments over here. But this simple command is just going to create a pod and run one container in that pod where the container is going to be running our friend uh, the Nginx image. And because I haven't given any kind of qualified name to it, it's going to get Nginx from Docker Hub. Yeah. If you want to get an image from another uh, another Docker registry, then you just give the name of the registry here in front of it. Or if it's one of your own images, you just specify your account name and all that kind of stuff. So it's the exact same really as with uh, deploying containers into Docker Desktop. So, if I go back to my VS Code, if I want to see what pods I currently have, it's simply OC get pods. Is that right now? Get pods. And it's telling me that I don't have any pods at the moment, which is right. And if I now go OC run, and you can see I ran it earlier on, and I just hit return. It's confirming now that it's creating the pod. And if I run my get pod again, it looks like that my pod is currently in a running state, which is good. So the way you interpret this here, right? So this is clearly the name of the pod. The 1/1 here means that there's only one container in this pod, and that one container is currently running. It's ready. If there were two containers and both of the containers were in a running state, you'd get 2/2 and so on and so forth. Overall, the pod is in a running state and the pod has never been restarted. Restarting pods is something that happens a lot, but unfortunately, if for whatever reason a pod uh, crashes and or is deleted, Kubernetes will automatically try to restart that pod. And so the number here would start increasing. And this is how old it is. If I want to get a little bit more information, I can go /o for output wide. That's kind of telling me that I want a little bit more information on my pods. And we can see now actually over here that the pod is running on worker node 2. Remember, there were 3 worker nodes, worker 0, worker 1, and worker 2. So it has assigned my pod to this particular worker node. And is giving me the IP address. Yeah, there's the IP address of the pod. But again, that is internal to Kubernetes. The other stuff we needn't worry about really. Let's see. The nominated node, you can actually specify that you want your pod to be started on a particular worker node. There may be cases when that's desirable. Maybe there's, okay, all worker nodes may not be equal. Some worker nodes may have certain hardware resources associated with them, and those hardware resources you actually want for your particular pod. Yeah. So you can nominate a node for the pod to run on. The readiness, like a pod goes through a series of phases before it gets to the running state. Um, and the readiness, and you can specify when you create a pod, you can specify, let's call it a little script that you want to have executed, and that the purpose of that script is to test that your container within the pod is ready to receive requests. And if that script returns a successful response, then that signifies that the pod is ready. Its readiness state is such that it can now receive requests. So, some containers may take a number of seconds before they're in a position to receive requests. Didn't apply in our case though. And that's about it really. So that's fine. That's the 101 of creating a pod. So we did the OC get pods to check status of all our pods, and that was kind of the response we get. Now I'm saying here, so a pod now is what we refer to as a resource in Kubernetes language. Some people refer to them as objects, but resources probably would be more common. But creating these resources from the command line, as I did up here, clearly that's not great. You'd like to be able to automate it in some way. And that is available to us in Kubernetes. And really, it's that automated way or that kind of scripted way is the way we would do it ordinarily. You'd very rarely run the OC run command to create a pod for yourself, unless you were just just playing around and doing some debugging maybe. So instead, what we do is we create what are called manifest files. And these manifest files, which I mentioned, where do I mention manifest? Termed manifest files. These manifest files are essentially a kind of a declarative way of describing the pod or pods that you want to have created when you run. So this declarative code is code, and so we run the code. And when we run the code, its end result is to create a pod or set of pods for us. We write these manifest files either in YAML format or in JSON format. I don't think I've ever seen JSON used. It's nearly always YAML that's used. And so that's really what we will be doing for the remainder of this part of the module. It's just YAML files that you'll be writing and running though. And well, we don't say run really, we say we apply the manifest files. Apply essentially means you hand them over to Kubernetes and it kind of executes the contents of those manifest files. If I can just go back for a second, when I ran this command here, OC run nginx, like what was actually happening there is, if I go way back to here, right? OC is the CLI for Red Hat Open Container Platform. That's called a Kubernetes for short, Red Hat Kubernetes. So the OC client is what I was using. And when I hit the return on that command, that command was sent across the network to the API server that's running in one of the master nodes. Let's call it the main master node of our cluster. And the API server asks the scheduler to schedule a pod for this request. What the scheduler does is it consults with the etcd, which is essentially kind of a database telling us the state of all of our worker nodes over here. And the scheduler makes a decision as to which worker node it should schedule our pod on. Yeah. And as we saw, it picked worker node 2 in our case. So having selected the worker node, it then tells it kind of hands control over to the kube controller. And the kube controller then communicates with the API server, telling it to schedule a pod that's going to run the nginx image in it, and et cetera, to to um, to communicate. It's kind of asking the API server to communicate with worker node 2, and it communicates with the kubelet component within worker node 2, and it's the kubelet component that takes care of creating the pod and getting it to run the nginx image. Strictly speaking, actually, what happens once the pod is created, initially kind of it's an empty pod, and the pod actually makes a request to kubelet, which makes the request back to the API server to go to Docker Hub and download or pull the nginx image. And that's downloaded, handed back, handed to the pod itself. And the pod now kind of takes care of starting up the nginx container within it. Okay, so there's a lot kind of happening behind the scenes. We don't really necessarily need to be conscious. Well, we can be conscious of it, but we're never going to be debugging all of that kind of flow of control. That's taken care of by Kubernetes, obviously. But that's kind of what's happening behind the scenes. So all of these elements or components or modules of the Kubernetes platform, they're all kind of working behind the scenes for us. So, and we finish up with our pod and our container running inside that pod. In a while, we'll see how we can actually send a request to that container, which would make sense in this case because it's running a web server. And it's really going to be using port forwarding, which we're kind of familiar with as a concept from Docker Desktop. Okay, so back to so we don't like starting pods using this form. Instead, what we'd like to do is write, uh, describe in declarative code what we want to achieve. And so let's look at what the declarative code looks like. So I said that a pod is a resource in Kubernetes speak, and there are lots of different types of resources. In fact, if I do something like this, if I want to get the full list of resources that's supported by Kubernetes, if I go OC, API resources, let's get rid of that. Then there we go. Loads and loads and loads of different types of resources. And one of the resources we know now is a pod. And if I just run that command again, actually, now we could look through that list there to find the entry for pod, but kind of an easier way of doing it is to maybe use the grep utility. I don't know if grep is available on Windows or not. It's mainly a kind of a Linux utility. If I do a grep on pods, then here it is here. Now, uh, there are a couple of resources. We can see there are a couple of resources that have pod within their name, but the one that we're actually interested in is the one where pods is the entire name of the resource. If I run the long command again, and if I go right up to the top of this list to see what does each column represent. Right. Um, so the columns in this information here, right? Let's see now. Um, well, we have the name of the resource, and that's really only for our purposes. Okay. We have the short name. The short name for pod is just PO, and after a while, you'll get used to knowing what the short names, because, okay, pods is only 4 letters, but some of the resources have quite a longer kind of spelling. And so familiarizing yourself with the short name just means you have to do less typing really at the command line. So there's the short name as well for every resource. There is the API version of the resource. That's kind of important when we start looking at these manifest files. So each resource has an API version. Some of them have the same API version, but others don't. So you need to know what is the API version for whatever particular resource you're trying to create is. Um, a resource also has a kind value. The kind for pods is just pod. And they're probably the most important things to know about a resource. The name of it, its short name, its API version, and its kind. Those four kind of attributes of a resource. And so if I run the command again with grep in it, so the short name for pods is PO. Its API version is just V1, and its kind is pod. Yeah, that will become useful to us in a few seconds now. Right, back to manifest files. So you can see here there's a number of YAML files, and we're going to work our way through these. And each YAML file is responsible for creating a different type of resource. Although in our case, they're all kind of related back to pods, but uh, they're creating different resources. Here I have in file 00, it turns out that no matter what type of resource you want to create, in terms of the YAML file or the manifest file for it, the file has to have the API version of the resource. You have to specify what is the kind of the resource. So, for example, pod in our case, the API version for pod, you noted there was v1. So the value we would give this attribute would be just v1. The value we would give the kind attribute would be just pod with capital P. There's metadata that you need to associate with the resource that you want to create. Now, the metadata would include what name you want to give to the resource, the labels that you want to give to it. Now, it turns out these labels are actually very important. As I did mention to you there in passing, when we create, let's say, a pod, for example, which is a type of resource, we can give that resource a name, but that name is really mainly for our purposes. Kubernetes internally doesn't use it at all, hardly. We can associate labels with a resource. A label is just a key value pair, and you can have a number of different labels, and they're completely arbitrary. In most cases, there are some predefined labels, but in the main, the labels are completely up to you. They're arbitrary. But it's those labels that Kubernetes uses internally to identify particular resource instances. So when it's looking for a resource, you don't tell it, go find the resource whose name is whatever. Instead, what you would say is, find the resource or resources which have the following label or labels attached to them. And as well as name and labels, you can have annotations. We will see one or two annotations. Annotations tend to be predefined key value pairs, whereas labels are completely arbitrary key value pairs. And the final thing then that pretty much all resources need is what's called a spec or specification for that resource. And that's where you would have a lot of detail about the particular uh, uh, configuration of the resource. So those four fields you will have in every manifest file. And so let's look at a manifest file for creating a pod. And it's this one here. The API version. Sorry, there's something in my way now here on Zoom. I'll just move this for a second. The API version must be set to v1 when it's a pod, and I showed you where we got that information from when we ran the OC API resources command. The kind is pod. Now the metadata, in my case, the metadata, I'm giving a name to the resource, which again is the name is completely arbitrary. I'd ignore these guys for now. And in terms of labels, I'm giving two labels to my resource. And again, at the risk of repeating myself too much now, the labels are just key value pairs and they are completely arbitrary. So I've decided to use a label called app. A label called team, which I set to integration, and a label called app, which I set to do, as in a to-do app, I guess. The last part then is the specification for this resource, and that's where the most information is contained. If I just pull down, so I want to pull down this guy. So because the resource is a pod, then the specification is really a specification of the containers, plural, that I want to have running inside that pod. And so I'll skip over this line for a second, but here we go. We're specifying our containers, plural, and so it's an array. And in YAML, as you know, uh, whenever you're uh, whenever you're initializing an array, every line has to begin with the dash symbol. So the dash is telling us that this property here is an array as opposed to an object. And so this is the specification for in my case, I've only got one container, and I'm giving the container a name. It's somewhat arbitrary, the name that you want to give it. Clearly, this is where I'm specifying the image that I want the container to run. And here I'm talking about the ports that I want the container to expose. And I know that because I'm using the Nginx image, then I need to expose container port 80. But again, ports is actually an array property. So there may be more than one port that my container image exposes. We've never had a case where it does expose more than one, but you could well imagine some container images may want to expose more than one port. For example, if I wanted to do an SSH to the image, then it wouldn't be port 80 I would use port 443 or whatever the SSH port is. Or if I want to use some other protocols to communicate to the container. Okay, so this is our first look at this notion of these manifest files. And when you create a manifest file, what you do is, in terms of executing that code, and by executing we simply mean pass the file up to Kubernetes and let it execute. And the net result of the execution of this manifest should be to create a pod where the pod's name is, what did I call it? The pod's name is Nginx pod 1, and it will have the Nginx um, an Nginx container running within it. Of course, if I wanted to run a second container, I simply would, repeat something like this. Now I've got two containers. In my case, obviously, I cannot have two containers both using port 80. This would have to be using a different port. But it's as simple as that, really, to create multiple containers within a single pod. Now I don't want to do that, so if I can now go back to the command line, clear it first. And the command is OC apply in this case, and just -f, and then follow it with the name of the file itself. So in my case, the file is, in fact, it's that one. It's the 01 file. 01. And we're getting kind of confirmation now that it has created this resource for us. Is it telling us? Yeah, it's telling us it's a pod, and this is the name of the pod. So if I now go OC get pods, I should have two of them running. Yeah, so this was the one I created earlier on, and this is the new pod that's now running. So that's straightforward enough, I think. Let's go back to our slides. How are we doing on time? We're okay. So we have ran that command and it created the resource. You can actually have more than one resource in a YAML file, and we will see that later on. And you would separate the resources definitions with just the triple dash, but that didn't apply in our case. But then when we ran OC get pods, we saw what the result was. Um, and if you've got lots of pods running and you only want to find out about certain ones, you only want to get a certain subset of the pods, then what you can do is you can specify the label, minus L there means label, the label or labels of the pods uh, that you want to have listed by the get command. If you don't specify anything, then it lists all your pods. So if I ran this command here, minus L team equals integration. Now you might remember in my manifest file, I did assign this label to this particular resource, this pod resource. So if I run the command on the slide, well, let me just type it out, I guess. OC get pods. Then I'll just do a clear. Get pods minus L team equals integration. Hit return. And now it's only listing one of the pods to me, and it's the one that has that label associated with it. So these labels are very useful uh, from Kubernetes perspective. What are we saying here? The etcd stores lots of attributes about, oh yeah. So when we create pods, again, if I go back to our architecture diagram, all of the information about the pods are being stored in the etcd database. And there is lots of information about a pod. And if you want to get the full facts about a pod, then the command is ocd describe. So this is the describe command. And so if I run that command, now you can use the describe command for lots of different types of resources, not just pods. So I think you have to tell it that it's a pod that you're asking it to describe. And in this case, you do use the name. We are using the name for our purposes, but so again, if I just do OC describe, I can do pod or pods, each will work, and then we called it Nginx. And we'll just look at pod one, although it doesn't really matter. And so this is all of the information that's being stored inside in the etcd database about our pod. And a lot of it we've seen already. It's storing the labels that it has for the pod. All of the kind of networking related stuff, any volumes that are mounted on the containers, plural again. Here's some detail about the containers within our pod, any volumes that it has mounted, that a container is mounted. All of that stuff would be stored inside here as well. We'll see that later on. And if we go down to the very end of this information, um, here we have the kind of the process that a pod went through in order to get to its current state, and its current state is the running state. So, or if in the language of Kubernetes, these are the various events that happened to our pod. So initially, uh, you can see that the pod was scheduled to run on a particular worker node. Then it looked like what add interface means is that an IP address was assigned to the pod. Then it it starts pulling the image from wherever, in our case, Docker Hub. Eventually, the image is successfully pulled, and okay, it's now kind of fully created. The pod is now fully created, as in its containers are stored, are loaded into the pod, and they are uh, executed, or they're initialized, I suppose. Let's say they go through their initialization phase, and the pod is now kind of it's now ready. It has been it's started. It's in a started state. So these are the phases, let's say, that a pod goes through. And if we delete a pod and it gets recreated, these events would be added to this list here. We'll see that maybe in a while. So that's the full information that's stored in the etcd database about a pod resource. Let's see. We had that already, and we had the describe command as well, so that's fine. When you obviously, you will sometimes you will have, well, in most cases, you will have your own applications which you have Dockerized, and you'll be running those inside pods. But maybe there's some error or bug in your code or in the image, whatever, and you want to go debugging. So what are the debugging options available to us when we're running our contain our images inside pods up on a Kubernetes cluster? Well, we have our friend port forwarding available to us, and it works almost identical to the way we uh, practiced port forwarding with Docker Desktop. So here's the command that you use when you want to use port forwarding. So let's try that on one of our pods. And as you know, with port forwarding, essentially what you're doing is you're kind of linking a TCP port on your desktop to a port of a container within a pod. So let's try that. And it doesn't matter because both of our pods are running Nginx. It doesn't really matter which one we pick. So I picked Nginx pod 1, which was the one that was created using the manifest file. And I'm linking, and again, you can pick any port you want to. I'm linking port 3000 on my desktop machine to port 80 of the port 80 of the pod, I suppose you'd say. But we know that port 80 of the pod is linked to the containers port 80 because, that's what I have up here in my manifest file. So if we hit return on that, So there's a connection. There's quite a lot happening behind the scenes here now, but there's a connection made for us, and this connection has to remain open, obviously. So if I now just go to my browser and I go localhost 3000, then surprise, surprise, and I'll just do a refresh a couple of times. Okay, I'm now communicating with the web server running inside the container inside the pod. So that's one way you do your debugging. Obviously, though, if it fails, then you got to dig a little bit deeper. So a second option that's available to you is to look at the logs generated by the container internally. And so the command is oc logs and just the name of the pod. So if I do that, um, I don't have to. I could open up a separate terminal, but um, I'll just kill the port forwarding for now. I'll go OC logs, and we used Nginx pod 1. Okay, so a lot of the entries in the logs now was just when the Nginx web server was kind of booting up itself. But at the end of the log, this stuff here was generated as a result of me trying to connect to the Nginx web server from my browser. And I refreshed the screen so there was two requests sent from my Chrome browser to the web server. That's what you can see there. I mean, if I go back to the port forwarding again, and I go back to my browser, and I'll do a number of refreshes. I've done 5 refreshes. Go back and look at the logs. Okay, you can see evidence of the requests being sent, number of requests being sent to that pod. So that's logs. And there's a third option available to us, which is we can actually uh, open up a terminal session within the container of our pod using the exec command, which is, very similar, if not identical, to the way we did it when we were running our container uh, in Docker Hub. And so let's try that. But you're very familiar with that now, so there's nothing new that you're discovering. But I'm just showing you how to do it when you're using Kubernetes. Yeah, and now we're inside the actual container. Now that container, remember, that container is running in a pod up on worker node 2 in my cluster. It's not running locally, obviously. Whereas when we were using Docker Desktop was running locally. Now, admittedly, Docker Desktop, I think I might have mentioned this to you before. Docker Desktop is quite sophisticated internally. Internally in Docker Desktop, there is a virtual machine running the Linux operating system. That's what's actually happening internally. So it's like a single node, if you like. Um, but that's just by the way, but it is all running kind of on my local machine. Whereas here I'm connecting with a container that's running remotely. Yeah, and I can do whatever I want to do. And let's exit out of it. Okay. I think I'm actually going to stop here and pick up the story tomorrow, and I'll do a little bit more on the slides. I'm not going to take the entire 3 hours now. We'll just do an hour and maybe a little bit more, and then I will let you work on your assignment. And next week we'll uh, we'll have a Kubernetes lab, and essentially you'll be going over the commands that I'm going over here and creating manifest files. All right, we'll leave it at that. I didn't give you an opportunity to ask any questions, but again, as I've said it on day one, really, if you ever have questions, just feel free to interrupt me at any stage. All right, I'll talk to you tomorrow morning. Thanks. Bye bye.